Okay, test. Get your radical sheet. And you get this sheet here. Tells you how to set up multiplication, dividing, either radicals or rational exponent expressions. And then on the other side, it tells you how to add and subtract them. So, well, here's the first one. Got the square root 200 times x to the 6 times b to the 7th. Okay, it looks like a multiplication problem if there ever was one. Okay, so you're going to go with, I'm going to make the 6 lines, map, lay that out so I know you can see what's running through my head. Okay, first off, you have a radical. This is a radical. You need to write it as a rational exponent. So put equals, make a parentheses. You have a 2, so it's going to be a 1/2 power. Then you're going to have 200 times a6 times b to the 7th. These are exponents. So we have 200 times a times b. 1 times 1/2 is 1/2. 6 times 1/2 is 3. 7 times 1/2 is 3 and 1/2. None of those are negative. Get this out of here. One of them is negative. You got to move it. Okay. Okay, so your wholes are 3 and 3. So a to the 3 times b to the 3. Then your exponents times 200 to the 1/2 times b to the 1/2. Okay. Now you have these 1/2 powers. That 2 indicates it's a square root. Okay, so is 200 a perfect square root? Yeah, I don't see it. Okay, and b obviously isn't, since it's a variable. So those have to stay for now. They're not on the bottom though, so out. Now you need to make those into radicals. These are not radicals. They're whole exponents. You drop those. And these have 2's, so you make a square root. Cross those out. 200 times 1's 200. And then b to the first is b. Okay. All right, now a to the 3rd times b to the 3rd. Now you make a radical 2. Put your b in the radical. You need to see what you can get out of that 200. Make it into 2 radicals, divide it. 200 divided by 196 a decimal, 169 is a decimal, 144, 121 are decimals. You divide by 100. 200 divided by 100 is 2. So the square root of 100 is 10. Okay. So you put a times 10 right there and a 2 inside. Okay, number 2 is almost exactly the same process as number 1. Do me a favor, cross out that 250 and put 125, please, because I said so, please. So multiplication again, nothing but multiplying. First off, you need to get rid of the radical. Okay, 1/3. Inside you got 125 times x to the 6 times y to the 5th. So my factors are 125 times x times y. So you put the 1 there. 1 times 1/3 is 1/3. 6 times 1/3 is 2. 5 times 1/3 is 1 and 2/3. 2, 1. Okay. x2, y1. Okay. Then you put your fractions, so 125 to the 1/3 power, y to the 2/3 power. Well, these indicate these are cubed roots, and what do you know? 125 is a perfect cube. It's 5, so this now becomes 5 to the power of 1. Okay, and it's no longer a fraction. It's 5 to the whole power of 1. This fraction stays, but it's not on bottom. Okay, now we're going to need this line because we have to make a radical for that. But the whole exponents we just bring down. X second, y to the first, just write as y. 5 to the first, you just write as 5. Now make your radical of a 3, and then inside you got y second. Now technically outside the 5 is supposed to come first. I'm not going to dock you if you don't do that. That's okay. I'm just showing it. Then you got a radical 3, but inside the radical just sits the y to the second. It's a letter, can't simplify. Okay, number 3. This is all multiplication. And you have radicals, it tells me we're going to need these, okay? Okay, now, they're both, you have 2 radicals, but they're the same that you're multiplying, so we're just going to round it up into 1/3 power. Now, you need to take the 3 times the 2. 3 times 2 is 6, but that's outside. Now, inside, 5 times 50 is 250. Y to the 3rd times y to the 4th, you add the exponents, y to the 7th, okay? So you have a 6, a 250, and a y. 6 is to the first, and it's going to remain to the first because it's not in the parentheses, okay? Then 1 times 1/3 is 1/3. 7 times 1/3 is 2 and 1/3, okay? No negatives, okay? 1, 2. So we have 6 to the 1 times y to the second first. Then you got 250 to the 1/3. And then y to the 1/3. Okay, so you got these cubed roots. Unfortunately, 250 is not a perfect cube, neither is the y variable. So we got fractions still, but they ain't on bottom, they're just on top. Okay, so these are whole exponents, okay? So you can just write 6 times y to the second. Then you turn these into a cubed root. They're the same. So then those are gone. 250 to the first is 250. Y to the first is y. So you got 6 times y to the second. Then you make your radical of 3. Put your y inside. Then you want to see if you can simplify the cubed root of 250. You want to get as much of that out as you can. So, perfect cubes. 250 divided by 216 doesn't work. Divide it by 125, that does work. 125 and 2. This becomes 5. So you put times 5, and that's 30. Then in the radical, you put 2. 30 y to the second, cube root 2y. Number 4, I need to change this problem, okay? Otherwise, this is going to be a big conundrum, okay? I want you to make that 5 into a 3, please, because I said so. Now, so you got a cubed root and a square root. Now, the hint's multiplication again. Now, the hint tells you, gee, I have a 3 and a 2. Well, that's probably a good indicator. We're not going to be able to put them into 1, so that's why there's 2. You need 1 to the 1/3, and the other one to the 1/2, and you're going to put 3's inside them, okay? So we have a factor of 3, and another factor of 3, which I'll just add the exponents together. So that's going to be 1/3 plus 1/2. 1/3 plus 1/2 is 5 over 6, okay? Now that's not a negative. So we got 3 to the 5/6 power, okay? Now, I have 6 roots on the back side. 3 does not happen to be one of them, so that stays. Then what you need to do is make that into a 6th root. It's not on bottom, so you're not worried about having to make it whole, okay? Now watch what I do. It's 3 to the 5th power, so I don't want to just put 3 in there. I put 3, I find what 3 to the 5th power is. It's 243. Okay, so you have a 6th root. See how much of that you can get out, which I don't think you can get out any of it. 64, no. Well, I'm not doing 1, okay? That'd be stupid. It just ends up the same, okay? Okay, number 5. 4th root of y to the 6th divided by the 3rd root of y to the 2nd. Again. Well, another hint. You're not going to be able to minus the 2 from the 6 because they're in different roots. So you need 2 separate ones, 1/4 and 1/3. y6, y2. So we got y over y. 6 times 1/4 is 1 1/2. 2 times 1/3 is 2/3, and you subtract 2/3. 1 1/2 minus 2/3 takes me to 5/6. Y to the power of 5/6. It's positive. Okay. Okay, so we have the fraction 5/6 as a power. Obviously, I'm not going to be able to get rid of it because it's y. So it's not on bottom though. It's on top, so I make a 6th root, and inside we put y to the 5th power. Now, obviously, you can't simplify that. That would be our final answer. Okay, this is another multiplication problem. That's an exponent, okay? But I don't see the radical. You don't need to worry about that because there is no radical. It's already in the rational exponent form. So you go to work. 25, so you're not trying to rewrite or change anything. What you are going to have to do is move that to the bottom so that the exponent turns to positive, put a 1 over it. So it's 1 over 25 to the 3/2 power. So you got a 2, not for long I don't, because on the square root list, square root of 25 is 5, okay? Now, I don't have any fractions. I don't have them on bottom, and I don't have a fraction in the numerator, okay? The only exponent I have is a 3rd power, and it's a whole exponent. So all I got to do is figure out 5 to the 3rd. It's 125. Booyah. Number 7, x to the 2/7 power times x to the 3/14 power, okay? Obviously, multiplication. I don't see any radicals. They already are in the fraction exponent form, rational exponent form, I should say. So we go to work. X, you add the 2/7 and the 3 over 14. Okay. It's going to be 10 over 21, I believe. Let's check to be sure. Or no, 1/2. I was a little off on that. It's not negative. So you got a 1/2 power with a base of x. You can't really do anything for now. It's not on bottom. This is to use if you have a fraction exponent on the bottom at this stage. Okay. Okay. All right. So you make a square root and x to the 1st. Okay. Well, there's nothing I can do with that, so that's the answer, the square root of x. Okay, number 8, 64 times y to the 11th. Actually, I'm going to get lazy. No, I'm not. Okay, I'm going to get lazy here. I'm going to make that a 12. Okay. 64 times y to the 12th times x to the 6 divided by 125 times y to the 4th times x to the 12th, and then that whole thing's to the 2/3 power. It's all multiplication. You already have your rational exponent. You don't need to rewrite it. So you have 64 times y times x. All multiplication division problems, we set this up. 125 times y times x. Plan on crossing out one of the y's and one of the x's on this step. So 1 times 2/3 is 2/3. 12 times 2/3 is 8. 6 times 2/3 is 4. 1 times 2/3 is 2/3. Okay. 4 times 2/3 is going to be 2 2/3. Okay. And 12 times 2/3 there is going to be 8. So we get rid of the y to the 2 2/3 and subtract 2 2/3. That is 5 1/3. Then you take out your x to the 4th and subtract. It's x4 down there. Okay, so we got a 2/3, a 5, a 1/3, a 2/3, and a 4. Not a single one of those is negative. Okay, so your wholes, you got 5, you got 4. So y to the 5th, x to the 4th. Now you put your fractions. Okay, so 2/3 with the 64, and then 1/3 with the y. Then bottom 2/3 with the 125. Now, those rational exponents, see if you can make them whole really quickly. well, a cube root of 64 is 4, so this is now 4 to the 2 power. Cube root of 125 is 5, so this is now 5 to the 2nd power. That 2 is still up there. Okay, and that fraction stays, that one stays. Now, the bottom only has whole exponents, a 4 and a 2. The top has a fraction, so we have to actually write that into radicals. So the y to the 5th and the 4 to the 2nd stay the same because they're full exponents. But the fraction, I make a cubed root and put y inside. Now on the bottom, you got x to the 4th times 5 to the 2nd. Actually, at some point, you got to make that 16 and that 25. Okay, so that's 16, 25, then the y to the 5th, the x to the 4th, then the cubed root over y. Answer. Number 9, okay. B, that's a letter B, cubed root of B divided by the cubed root of 2 times A. Once again, now I gave you a little clue here. Denominator has to be rationalized. That means no fraction exponents on the bottom. You can't make a radical on the bottom, which we're not going to if you follow the procedure. They're both the same root, so we make just one parenthesis to the 1/3 power, and you're going to have a B over 2 times A. You can't divide any of that or simplify it. So we got B 2 times A. 1, 1. So all these are distributed to the 1/3 power, making them all 1/3 powers. No negatives, okay? Bring them over. B to the 1/3, 2 to the 1/3 times A to the 1/3. Circle all those 3's. B and A aren't going to be, and then 2, no, okay? Well, you got fraction exponents on the bottom, so we need to come down here. You write your B to the 1/3, just the top stays. Now space these out, 2 to the 1/3, A to the 1/3, and you need to times by a second factor at 2. You take 3 minus 1, that's 2, okay? Now you also got to times the top by 2 to the 2/3 power. Now the A, you're going to times by A, put a 3. 3 minus 1 is 2. You're going to times the top by A to the 2/3 power. Now what happens here is this now just becomes 2 to the 1st, which is 2, and this is A. So 2 times A, 2 times A. Now you obviously have fractions on top. They all have a 3 inside. You want to do your, so then all these 3's go away. Now you got 2 to the 2nd's 4, okay? And then the variables B to the 1st and A to the 2nd. You can just put B if you want, then A to the 2nd. So you make your cubed root, B times A to the 2nd. Is there anything you can divide by the cube? Remember, you're on cubed roots now. 4 is too small, so that's going to be the end. You don't divide 4 and 2. 4 is a radical, 2 is not. Okay, that's on multiplication division. Now you're going to see adding and subtracting. Flip that over. Adding, subtracting, see if the radicals are quote-unquote like terms. If they are, you're done as long as a radical can't be simplified. Well, these are like terms. Look at your radicals. They're exactly the same. So you write the cubed root of 5x. And what that allows you to do then is add the outside coefficients, 8 and negative 18. That adds to negative 10. Okay? Okay, next one. If you want coefficients here, put 1s. If not, that's fine. But the radicals aren't the same, okay? These all different. Well, since you can't do that, you need to simplify the terms individually, rewrite the problem, and then see if anything goes together then. So, you got 1 with the square root over 72. You got 1 with the square root over 32. You got 1 with the square root of 8. Drop your 1. 72 is not a perfect square, so you divide into it. You're not dividing it by 9. There's a higher number than 9. Because if you don't divide by the maximum possible number, you end up with the wrong answer. 36 is 2. Okay, square root of 36 is 6. So 1 times 6 is 6, radical 2 over 2. Okay, now drop the 1. 32 is not a perfect square. You divide into it. 32, it would be divisible by 16. 16 over 2. Square root of 16 is 4. 1 times 4 is 4. 4 radical 2 over 2. Then you drop your 1. Eight divided by 4 is 2. Square root of 4 is 2. 1 times 2 is 2. 2 square root over 2. Well, all those radicals look like they match, so I put the square root of 2, and we add 6, 4, and 2. That's 12. Okay, well, we definitely have adding. Put 1 in front of that. Okay. But we have these parentheses we have to multiply. That's the FOIL method. You're still on the adding side, okay? You just need to get rid of the parentheses. So you distribute 8 to 2. 8 to 1, square root of 2. I'm not even going to bother to put the little 2's in because on a FOIL it's nothing but 2's. You're just going to look at this square list. 1 square root of 50 times 2. 1 square root of 50 times 1 square root of 2. That's going to be 16. It's going to be 8 square root of 2. 1 times 2 is 2. Put the square root of 50. 1 times 1 is 1. Then you multiply 50 by 2. That's 100. So what do we have? Well, we got 16 plus 8 square root of 2 plus 2 square root 50 plus 1 square root 100. Okay, now obviously nothing goes together at this juncture, okay? So simplify them individually. You can't, 16's already simplified. And these 3 are coming over here. 8 square root of 2, 2 square root of 50, 1 square root of 100. 8. I don't believe you can divide 2 by anything on this. That will stay the same. Drop your 2. 50 is not a perfect square. You divide it into 2. This one needs to be a perfect square. 50 divided by 36 decimal. 50 divided by 25 is 2. Two times 5 is 10. 10 square root of 2. Okay, drop your 1 down. Don't divide that because the square root of 100 actually equals 10. 1 times 10 is 10. Okay? Okay, now, well, these would go together then. That'd be 26, and I'd put the square root of 2. 8 plus 10 is 18. Don't add the 26 and the 18. Okay? That's multiplied by a square root of 2. That's not multiplied by anything. That's your answer. They're not like, they have to be multiplied by the same thing for them to be like terms. Okay, next one, minus, plus, negative. Put a 1. You might as well put a 1 in front of that. Radicals are not the same. We need to simplify these terms individually. It's just 2 of them, though. Okay, so 1 square root of 300. They're square roots. Negative 1. I don't care if you put the little 2 as long as you know what list you're looking at. Drop the 1. 300 is not a perfect square. It divides by 100. 300 divided by 100 is 3, and this becomes 10. So it's going to be 10 square root 3. Drop your negative 1. 75 isn't a perfect square. Then you get decimal, decimal, decimal. 25 works. Don't put 25 and 5. 75 divided by 25 is 3. This could be negative 5 square root 3. Now they match, so I put square root 3. 10 plus negative 5 is 5. Okay, solve the equation. That means you're solving for what x is. Oh, x is inside a radical. You better circle that and look at what you have outside the radical. Well, we got a times 3 and a minus 3. You got to get rid of the minus 3 first. You're going to plus 3. Then you have this times 3, so you need to divide by 3 in that order. Plus 3 to the 9. What's up, man? Then 9 plus 3 is 12. Then you're going to divide by the 3. Get to see the master in action. So the square root of 2x. And then 12 divided by 3 is 4. Okay. Now, time to get rid of Mr. Radical here. So you take both sides to the second power. And then 4 to the second, 16. Divide by 2. Divide by 2. And x is 8. Who's watching? Already needs some. Okay. All right, next one, number 15. We got the quantity 2x plus 3 to the 3/4 power minus 3 equals 5. Okay. So, what's that?
I could do that for you if you want. No.
Hey, it works. I can use them year after year then. Okay, that's the point.
That's a good deal.
It is. See ya. Okay, this one here, you're solving for x. Now, x is inside a quantity to a power of 3/4. And then you got minus 3 equals 5. Okay? Okay, so let's replace the whole quantity with h. Okay? When I have a quantity and an exponent, best off just simplifying the quantity. Minus 3 equals 5. Now, don't forget to make your table, because we might bring the 2x plus 3 in twice. Maybe we won't. We'll see. Okay, now this is your exponent. You got to get rid of the minus 3 before you worry about that. So plus 3, and that's 8. Now, how do you undo a rational exponent? You reciprocate it. You flip it to 4 over 3. Now, cubed root. Now, would that be that's an odd. So that's not positive, negative. It's just whatever the cube root of 8 is. See? Answer needs to be positive or negative, one or the other, not both. So the cube root of 8 is 2. We don't put the plus minus on the 2. Okay? So it's 2, but don't forget about the 4th power. So h is just equal to 16. So we don't need that side. I just put 16. Then I get the x by itself. I minus 3 to get 13. Divide by 2, and we get 6.5. Okay. Okay, another equation solving. The square root of x plus 7 equals x plus 1. So I think I'm solving for x here. Okay. Now, it's kind of like the first one over here where the x is inside a root. So I circle the root, quickly realize, oh, there's nothing outside the root, so we need to get rid of the root. You get rid of the root by taking both sides to the second power. So the side with the square root in the second power, I get a cancel, and I just drop the expression x plus 7. But on the other side, see here when I did the second power, it's just a 4 to the second, which is 4 times 4. But here it's an entire expression to the second. So what I need to do is write that out twice and do the FOIL method. So 1x times 1x. 1x times 1, 1 times 1x, 1 times 1. So it's 1x squared, 1x, 1x, and 1. Now, simplify that and bring it over here. Don't forget about the 1x plus 7. So it's 1, 1 plus 1 is 2, and then you got 1. Okay, so we have 1x to the second plus 2x plus 1. Now, at this point, you should realize, gee, I've got x to the second now, so there's going to be 2 answers, and I have x second and x. I have to apply factoring properties. Okay, so equals 0. Well, you need a 0, so we're going to get 0 on this side. We're going to minus 1x from the 2x. Then we minus 7 from the 1. So that'll take me to 0 on one side. And you're going to have 1x second, 2 minus 1 is 1x. 1 minus 7 is negative 6. Okay, now factor it. It's 3 terms, GCFT. GCF's 1, so get that out. 1 times negative 6 is negative 6. That is a mismatch. You're trying to add to get to positive 1. 1 and 6, no. Divide by 2, you get 3. That's negative 1. All you got to do is make it plus 3, negative 1. So put in the negative 2 plus 3. Now what's the A? 1 times x to the second. Oh, 1's easy enough to handle. The power needs to be divided in half by 2. It'd be x1, which is just x. So we have x minus 2 times x plus 3. You don't need the 1's. Okay, so x minus 2 equals 0. X plus 3 equals 0. So we add the 2, and we get 2. We minus a 3, and we get negative 3. Okay. Okay, last one, graphing radical functions, identify the domain and range. Okay, so 3 times the square root of x minus 2. Okay, well, I'm going to shorten this, so that's just y equals the square root of x. So I make an input-output table, and the x is in a square root, so I'm only going to pick numbers where I know the square root instantaneously, perfect squares, 1, 4, 9, and that goes on and on and on. I'm going to put 3 continuation dots. I might suggest you do the same, okay? But you can't go this way, okay? That's a stop, because you can't put negatives. So what's the square root of 3? 3. 9's 3. Square root of 4 is 2. Square root of 1, 0. Now, we got to adjust the graph so it fits the function. Is there anything in that radical other than just x? No. So put a check there. You're not doing anything to the x. Now, outside is what affects the y. So you got times 3 minus 2. You need to times 3 first, then minus 2 to all these outputs. 3 times 3 is 9, minus 2 is 7. 2 times 3 is 6, minus 2 is going to be 4. 1 times 3, and then 1, and then negative 2. Okay, you can go by 1s on each side. Guys, remember, this is the x, this is the y. So start with your 0, negative 2. So x is 0, okay, that's in the middle. Negative 2 down there. That's your stop point. Please label it. Then 1, 1. Okay. 4, 4. Keep going. 9, 7. 9's at the end. 1, 2, 3, 4, 5, 6, 7. And remember we said we could keep going that way, so I go that way with the arrow, not this way. Okay? Now, domain. Now, there's a restricted domain because it doesn't go on each side. Okay? Now, this is your x, y. So you put x with 0, you put y with negative 2. You can do it now, as far as your signs go, your greater than, less than, you can think of it one of two ways. You can just look at the table and say, gee, from 0, 1, 4, 9 is greater than 0 or equal to. Or also you can say, okay, on the x-axis that's going to the right, which is the x is increasing when you go to the right. Okay? Now the range, gee, negative 2, 1, 4, 7 are all bigger than negative 2. So greater than or equal to. Or you can look at the graph and say, okay, y is up and down. That graph's going up from that point. So up is greater. Okay? All right, now this one, I'm going to add something to this. I'm going to put a negative 1 in front. Y equals negative 1 times the square root of x plus 4. And then after the square root, we have minus 5. Okay, I'm going to set it up saying it's a square root. Okay, so perfect squares, 1, 4, 9, and they keep going. But they do not go into the negatives, that is stop. So 3, 2, 1, 0. Okay, now, inside the square root, we actually have something, x plus 4. You can either do one of two things. You can set that equal to 0. You get negative 4, so you know you're going to have to minus 4. Or you can just look at inside and do the opposite of what that operation is. Inside the radical does the opposite to the x. Now, outside, you need to times negative 1 and minus 5 in that order. Okay, so 9 minus 4 is 5, 4 minus 4 is 0, 1 minus 4 is negative 3, 0 minus 4 is negative 4. Then take all these outputs times negative 1 and minus 5. So that's going to be negative 8. 2 times negative 1 minus 5 is going to be negative 7, negative 6, negative 5. Okay, you can go by ones. This is x, this is y. So, negative 4, negative 5 is a stopping point. Okay, then from there, negative 3, negative 6, okay? 0, negative 7, 1, 2, 3, 4, 5, 6, 7, 5, negative 8. Now remember, the graph goes continuously this way, but it doesn't go the other way, okay? I should not see an arrow on the left side of that. Okay, domain. So x, negative 4, y, negative 5. Negative 3, 0, 5 are all greater than negative 4, so greater than or equal to, but negative 6, negative 7, negative 8 are all less than negative 5. There it's going, you know, these numbers are less than negative 5, so now it's less than or equal. Or also, the x is going to the right, so greater than. Now, as far as vertical, it's going down, so less than or equal to negative 5.